Alright, so postulates and theorems. Now, we're going to start with postulates today, and then we'll move to theorems later. But a postulate is let me make sure I word this correctly, is a statement. Wow. I know, I have to make sure I word it correctly though. That's what I thought it was. Alright, it is a statement. I just didn't want to miss any words, because then I didn't want us to get a vocabulary test and it not be the same words and then just blow everybody's mind. A statement that is accepted as true without proof. So these are just things that we accept in life. We don't have proof that they're real. We just know that they're there. Amen. So many words I could say. But I'm going to be Elsa. Alright, so then a theorem is a statement or conjecture that has been proven. Dun, da, 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 we're ready to go. That's it. That's all we need to learn to begin with. So then we have 7 postulates that we're going to talk about today. We're going to use them to prove that things are true, and then we're going to move on. Brianna, are you about to die? Are you about to die? Oh, okay. Okay, I'm just making sure. Your eyes look like they're about to roll back in your head, and I just didn't want you to die on me, baby. Why don't you put your head down for a moment? Okay, well, when you pass out, know that I tried. Please don't pass out. Please don't do it. Okay, so this is our first postulate. Through any 2 points, there is exactly one line. This is postulate 2.1. And what we're going to do is we're going to draw an example of it. So it says, through any 2 points, there is exactly one line. What should we start with? 2 points. Look at you go. Let's put point P here and point R here. And what should we draw through those 2 points? A line. Oh, look at you guys go. Take a point. No.
No, we just took one.
Now, it says that through any 2 points, there is exactly one line. Could we draw, y'all, I can't yell over you. Could we draw any other line through those 2 points? No, because it says there is exactly one line, so you can't draw another line through it. That's postulate 2.1. Isn't it lovely? Alright, postulate 2.2 is the next one. Is that a serious question? Well, why don't you count how many there are on the paper? Look at you go. Alright, so then this says, through any 3 non-collinear points, there is exactly one plane. What does non-collinear mean? Look at you guys go. Take a point. So what should we start by drawing? 3 points. Look at us go. So we're going to call this A, we're going to call this B, and we're going to call this one up here C. Now, are any of those on the same line? We don't have a line on there. Then we're going to draw a plane around it. And we're going to call this plane K. And dun da da da, we're done with that one.
You're so smart.
I'm telling you. No.
smarter than I am.
All right, are you ready for our next? Are you ready for our next one? A line contains at least 2 points.
So the line contains 2 points.
So what would we start by drawing?
A line.
A line. This is postulate 2.3, and we're going to start by drawing a line. And how many? And we're going to call it line N because we're fancy. Now, how many points should we put? At least 2. So how many could we put on there?
As many as you want.
As many as we want. So let's put 3. Let's call this C, D, and E.
Why aren't you giving her points?
Take a point?
That's 3 points.
Why are you yelling at me like that? Why aren't you giving her points? I'm sorry. That's it. That's all you have to do. Now, what's the next one?
2.4. Bit.
Postulate 2.4.
That should be a point.
And it says that a plane contains at least 3 non-collinear points. So, how many, what should I draw first?
A plane.
Look at us go. Let's go crazy and draw it the other way.
How you got that?
Whoa, we're so cool.
We are. It's like we've learned things. We're going to call this plane L.
That's fancy.
Remember when you name a plane, you use a cursive letter.
How do you do that? How do you draw that? You're good.
Are you serious? Okay. So, loop and loop and loop.
Oh, that's so cool.
Hey.
Let me do it again.
Loops. A loop.
Loop and loop and loop.
Oh.
Whoa.
Ravenclaw, can you get it together over there?
It's like this.
Alright, now it says a plane contains at least 3 non-collinear points. So how many points could we have?
You can have as much as you want.
But, so we need to have at least how many?
At least 3.
So let's call this P, let's call this E, let's call this B, and let's call this C. Dun, 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 dun.
Where's my points? I have to earn these.
Alright, so the next one says, if 2 points lie in a plane, then, Raven, then if 2 points lie in a plane, then the entire line containing those points lies in that plane. So this is postulate 2.5. So first we need to start by drawing a plane.
Hey.
And we're going to call this plane N. I'm sorry, I just started with N. Yes.
You got white out.
Alright, so it says if 2 points lie in a plane. So that means that I need to start with 2 points. So let's call this A, and let's call this B. And can we please stop talking while I'm talking? Thank you so much. Then the entire line containing those points lies in the plane. So all you have to do is draw a line through those 2 points. So what that's saying, we know that 2 points make a line. So if these 2 points are in the plane, then the entire line is in this plane. We did it. Look at us go. Dos más. And then examples. If 2 lines intersect, then their intersection is exactly 1 point. This is postulate 2.6. Man, it's like we've learned something. So this is 2 lines. And should we make them cross each other?
Yes.
Because it says that they intersect. So let's draw a line here. And let's call this line S. And let's draw a line here. And let's call this line...
Isn't it vertical?
Oh.
I'm sorry, I started with T. I'm sorry. I'm sorry for failing you.
It's alright.
Now, do those 2 lines cross? And do they cross at a point? And we're gonna ham sandwich. We're gonna call this point K.
Okay.
Now, here is the beautiful fun one. we have two planes intersect, and they intersect in a line. So everybody, please just bear with my drawing. We're going to start with a plane. And we're going to pray that it turns out. We are not friends, guys.
It's incredibly ridiculous.
Because I didn't use a ruler. But you know what? It's not my door, so it's fine. Alright, so then, yes.
Is that a letter?
That's an F. So then, my next plane is going to hit here. Dun, 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 dun. Yes, because we name planes with a 7.
I like to do that.
Okay, so the dotted line means it goes through it. And it crosses. Y'all just wait till we have to start drawing 3D figures and then see who's the artist out there. Okay? See who's the artist out there, you bunch of heifers. Alright, so those humana. These are two planes and they intersect at this line with those 2 points right there. And that's what that says. Are we ready to use our postulates?
No.
I want to see y'all's drawings if you think they're so fancy and you're wondering what mine are.
We can have a competition.
We can have a competition. That is not any better than mine.
I can't draw, but I can sculpt.
But we're not sculpting planes. We're drawing them. So can you draw a plane?
No.
I can draw that.
Y'all are so funny. Alright, are we ready, Tater Tots?
Probably sculpt a plane.
Are we ready for some
Oh, is that postulate or what is it?
Oh, thank you.
You're welcome. What are the points?
Yes. This is postulate 2.7. Super sorry.
That's just part of being human.
I'm not a human if I'm a mammal.
You're so
That's-
human.
I
Right?
This is better than yours.
No, it's not. She's just saying that to make you feel better.
Miss Asbury?
Yes.
The freshmen said their moms killed blood because they spent a lot of other time reading. I don't understand it.
You probably stand by
I can draw
Alright.
I mean, he's
Me as well, honey. Example 1. Explain how the picture illustrates that each statement is true. Then state the postulate that can be used to show that each statement is true. Okay. It's 2 buildings. Points F and G lie in plane Q and on line M. So let's find points F and G. Where do y'all see them at? Right here, because I'm looking at your paper. So you see them right here, correct? This is F and this is G. And they're trying to tell us that it lies in plane Q and on line M. So this is line M. Over here, this side is plane Q. So do we agree or disagree? Okay, so tell me how the picture shows that that's true. So where is line M?
At the top of building 1.
It's the edge of the building, right?
Yeah.
It's the corner. It's where those 2 sides meet. So line M is where the 2 sides meet. And we need to say that F and G are on that line, correct? So F and G are on line M. Now, what postulate says that if 2 points are in a plane, then the line is in the plane? What postulate did we just use that said that? Look back at your postulates. That if 2 points are in a plane, then the line is in the plane. What? Postulate 2.5? So, postulate 2.5. Fantastic. So we just write postulate 2.5. Dun, 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 we move on. All right, points A and C determine a line. Points A and C determine a line. Where are A and C?
On the edge of
On the paper.
This?
Yeah.
All right, so the edge of the roof.
Yeah.
So A and C are the edge of the roof. Please stop. And then, how do we know that 2 points determine a line? What postulate?
One.
2.1? All right. Postulate 2.1. Makes, Blair. Dun, 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 dun. Are we ready for always, sometimes, never? Alright, always, sometimes, never. If two, example 2 is where we're at, just in case you didn't know what was happening because you're talking. Example 2, determine whether each statement is always, sometimes, or never true. Explain your reasoning. So if two coplanar lines intersect, then the point of intersection lines is the same plane as the two lines. What does it mean for them to be coplanar? On the same plane. So if two lines are on the same plane and they intersect, then the point where they intersect is on the plane. Is that always, sometimes, or never true? Always. And what postulate is that? 2.6. Is it 2.6? I would say that's 2.4. Because postulate 2.4 talks about the lines being in the plane, right? Yeah. So you were right by saying that 2.6 is where the 2 points intersect, the two lines intersect at a point, but we need them to be in the plane, so that's postulate 2.4. All right, B, 4 points are non-collinear. Always, sometimes, or never true? Sometimes. All right, tell me an example of when it would not be true. When they make a what? Mm-mm. When 4 points are non-collinear, what happens? What do we create?
A square.
A plane. Jesus, take the wheel. Alright, so 4 points are non-collinear. Sometimes would be postulate 2.2. Because then it could create a plane. So 4 non-collinear points. You got A, you got B, you got C, you got D. If they're non-collinear, they could make a plane. Or you could actually have them all on the same line. C, line GH contains 3 non-collinear points. Is that possible? No, a line can't contain non-collinear points. So is that always, sometimes, or never? Never. Take a point. Alright, do 1 and 2 without me. Use the picture at the right. No, don't use the picture. Do 1 and 2 on the next one without me. Oh, I'm sorry. Thank you. So, a line can never contain non-collinear points. That means they're collinear. So, 2.3. Postulate 2.3 says a line contains at least 2 points. So that would be 3. Do 1 and 2 without me. Exactly 1 point. Remember what it's saying. Exactly 1 point. It is so hot in here. Yes, that is exactly what it is. Do you have an answer for number 1?
Do you?
I do.
I do.
What do you think it is? A line contains exactly 1 point. What's the definition of a line?
A line is straight.
That is not a definition of a line. How many points? So can it ever have exactly 1 point? No.
And that's 2.3.
Is it 2.3?
I'm asking.
You tell me. Alright, it says a line contains at least 2 points, so yes, that'd be 2.3. Take a point, Trey.
Bet.
Not point 2.3. Postulate 2.3. Alright, number 2. Non-collinear points. R, S, and T are contained in exactly 1 plane. Always. But could one of them be non-coplanar? Okay.
That's it. Okay.
Whoa. Whoa.
Thank you.
What definition is that? What postulate is that?
Is
2.2. Alright, what about 3? I'm sorry?
You said 1 and 2.
Right, but let's look at 3. You weirdo. Why is it sometimes, Miss Arrow? Because what could the lines be? They could be parallel, yeah. Both of you take a point. Good job. Sometimes. Dun, 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 dun. Oh my gosh. Brent. My brother.
What about postulate for that one?
It wouldn't be a postulate, you would just write parallel lines. Alright. Number 4, it says use this figure over here, and it says exactly 1 plane contains points F, B, and E. Is that true or false? That's false. Why?
Because B is not in the same thing.
F is not in the same plane, so false. F is not in the same plane. Sorry for my scribble. Not really.
I don't know how to do that.
Just make it like a kid.
Why do y'all not know how to draw cursive letters?
They didn't teach us that.
I never learned how to.
Well, we'll have a cursive day, okay? Not a cursing day, a cursive day.
Oh, we can't both.
No. 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 It's recording. Number 5, line BE lies in plane Q. So, could we draw a line through BE? Because it's 2 points and any line can go through there. So, if the points are in the plane, is the line in the plane? And what postulate is that? We'll look back. It is 2.5. Look at you go. Take a point. Alright. I don't know. Are we?
Yeah.
Your home. Oh, my sweet Jesus in heaven. Please put them back in the box. Your homework for tonight is this little half sheet. If you don't have the half sheet, please take a picture of the half sheet. I will zoom out, or you can come up here and take a picture of my page. I will even post it on Google Classroom and on the calendar. But for the love, take a picture of the half sheet. Now, do not line up at